Nano fam, welcome back. Hello everyone. Let me switch to the chat here. Hello Johnny, hello Antifnal, hello Gilmar, hello LFLF, hello Jubu, hello Pies. Welcome back everyone. Yeah, this week was really exciting because I got a lot of code ported. A lot of code. I could not join the dev meeting today, unfortunately, because I was working at for a client, and but now it's time to work on Nano again. Hey, ATXMJ, welcome. Rust Dev Stream 1401, hello. So let's add you all to the spinner wheel first, and then let's start the Bitcoin timer right away. All right, Bob is here. So many names already. So I hope I won't forget any one of you. Bob, ATXMJ. I don't think I have you in my address book. Let's search you. No. So if you want to take part in the Nano giveaway, just write your Nano address in chat, as usual, or you people who are already in the address book, you don't need to do anything. So everyone, please just check that you are on the wheel. If you're not on the wheel, just let me know. Oh, I think 1401 is not there. Yeah. Like that. Oh, ATXMJ. Has his Nano address here. Let me add you. TXMJ. All right. Okay, so yeah, please check that you are on the wheel, everyone. And let's start. So this last week, I focused again on porting only, and I did not merge any upstream commits, and I got a lot of stuff done, especially with my new computer, which is incredibly fast. Mary David, hello. So let's just quickly check the current state of the Rust port, and it looks so good. I'm really excited because the full Rust node is coming closer and closer. So what you see here is the dependencies of the node class, and the node class is the top level class, the main class for the whole Nano node. And as you can see, we have almost everything is ported now. And so this last week, I ported a couple of more classes. I ported, let's see, the schedulers. So we started last stream with the manual scheduler. So they are all in this scheduler component here. And last stream, we ported the manual scheduler. And the priority scheduler, which is the bucket system, was already ported. This we ported last stream, and during last week I ported the hinted scheduler, the optimistic scheduler, and then I ported the ascending bootstrapper, and I was surprised how much code that was. I thought this was just a single class, but the ascending bootstrapper was actually quite large, with lots of helper classes and stuff. And after that, I ported the request aggregator. So this thing. And the request aggregator was also a huge class. And even after that, I still had some time left. And I ported this one, the local block broadcaster. And this means that we now have almost everything ported. So the last bits that are still missing are the WebSocket server. And the WebSocket server is actually quite big and complex. So this could take a couple of days, maybe, I don't know, to port it. And the process live dispatcher, I have no idea what it does. And then there's still a bit of code left in the bootstrap for the bootstrapping, the legacy bootstrapping and lazy bootstrapping and whatnot. So we still have to port that, and then we're basically done. So then we have all the dependencies of the node ported. Then we can port the node class, and that will be quick because the node itself is mostly delegating. And then we have a working Rust node. So my guess is maybe 5 weeks, maybe 6 weeks. And then we have a fully working Rust node. Isn't that exciting, Nano fam? Oh, there's so many chat messages. I missed all of them. Mary David said, hello. Yeah, Mary David, share your Nano wallet address if you want to participate in the giveaway. Yeah, thanks, Andefnal. Yeah, Nardo ETH is here. So I know you are in the address book. So let's add you. All right. So we have how many minutes? 4 minutes left for the first Nano giveaway. So this is the current state. And so I thought I would just continue today working on the last parts, porting the last parts to Rust. And once we have all of that in Rust, these streams here will change significantly. I will focus on cleaning up the code then and on writing unit tests, and that will change. These streams fundamentally. So I think these streams will become a lot more interesting then. LFLF says, sounds great. Looking forward to 100% Rust. Oh, me too. It won't be 100% in the beginning because still all of the tests are in C++ and the RPC server is still in C++ and the command line interface parsing and stuff is still in Rust, C++. But yeah, I'm going to port those too. Just a matter of time. And then one day we are going to arrive at 100% Rust, I think. Yeah. So so my plan is to just keep on going here. And I started on Monday, I started working on the telemetry class, this one. And I think I got quite far. Already. And I stopped when I ran into a problem. And the problem was, so this is the C++ code. And this is the Rust code. So the problem was when I wanted, so I wanted to port the run broadcast and cleanup function. And then I noticed that here, this line, and then I stopped. It was already late. And then I ran into this problem on Monday, and then I stopped because I didn't know how to proceed here. And let's pick it up from here. So the problem we have here is the telemetry class. Let's see what it does. So I think it does periodically broadcast telemetry, and I think it does periodically request telemetry data from its nodes. Not so sure about that, really. Yeah, by the way, I think people think that I have a very deep understanding of the Nano node because I ported every line. That's not really the case, because actually it turns out you can port thousands of lines of code without actually having to understand what you're porting there. Because if you just think in if statements and loops and stuff like that, you can just happily port thousands of lines of code without actually knowing what you're porting. So So that's why I'm saying the upcoming streams will be a lot more interesting, because when we actually write unit tests for the code and we start to refactor it and clean it up and split it into smaller parts, that's when the actual understanding will come. So yeah, I'm excited about the future. So 30 seconds for the next Bitcoin block and the first giveaway. Yeah, so the problem I ran into in the telemetry class was, no, this is the Rust code. Let's go to the C++ code. So the problem I ran into was this line in run broadcasts, this line. And chat, do you see? What's the problem here? So maybe let's do the giveaway and maybe you can tell me. And if not, says, sounds like me. Don't know what I'm doing. Still get paid. Yeah, just kidding. Nano ETH, you won 1 Nano. Congratulations. I hope this is still your address. All right, and restart. All right, yeah. So, congrats, Nano. Yeah, so the problem with this code. The problem with this code is that it calls node. And node is the top level class. So this here is a bidirectional dependency. And Rust just doesn't work well with bidirectional dependencies. And in general, generally speaking, bidirectional dependencies are bad. So we have to refactor this so that there isn't a bidirectional dependency. This function, local telemetry, I already had a look at it, and this is how it looks. What it does is it just gathers the telemetry data. So as you can see here, it gets the block count from the ledger, it gets the bandwidth limit from the configuration, and it gets the unchecked count from the unchecked, what's the class name, unchecked map? Unchecked map, yeah. So what this function does is it just reaches into the components and gets some data for telemetry. And in the end, it signs all of the data with its private key. And yeah, that's what this function does. It is a factory function for telemetry data. Puking emoji from ATXMJ. Circular dependencies, yeah, that's bad, that's bad. Nano ETH says, thank you, looking forward to the full port to Rust. What are the expected benefits again? So the expected benefits is obviously the safety guarantees that Rust brings with it, and fearlessly refactoring. So with Rust, we can just change the code much more easily than with C++, because the compiler is very helpful and it just points us to problems. And yeah, so with Rust we just can work more easily with the code, that I would say, and then we can just make bigger and bigger changes. And yeah, ATXMJ says, and we have more than one implementation, and that's really good for the network, because imagine there would be there was a bug in Nano, in the C++ node, and chances are that the bug is not in the Rust code. And if not all nodes are affected by a bug, that is just, yeah, that's just hugely helpful for the network. Yeah, so we have to create the telemetry data, but we should not call the node class, because the node is the top level class. So I think the best solution would be to have this in its own object, maybe telemetry factory or something like that. Hamza Ali says, how much it will take me to learn Rust if I already know basics of C++ and OOP? Oh, that's... You can't really answer that. Like every person, every programmer is different. But if you already know C++, I think you should have it more easy than other developers. Because let's say if you come from Python, C#, Java, whatever, with garbage collected language, and you have to learn all of the memory management, then it is a lot harder. If you come from C++ and C, you will have you will already know that stuff. So I would say it's a good starting point. Okay, so we have to find a way to create the telemetry data without having access to the node class. So another option is we could just move this code into the telemetry class. I'm not a big fan of that because I think it would need additional dependencies like the unchecked map. Oh, what's that? The node version. I think we get this from CMake. Yeah. I already had a look at that. Oh, I don't know how to port that. Maybe we just hard code it for now. Set maker. Difficulty. Where does the difficulty come from? Network parents. Okay. And then we sign it in the end. So what would be a good first step to take here? Should we extract this into a class and then port that class? No, I think we should. So my thinking is, I think I wanna put this into the telemetry class for now, even though I don't think this is the right place, just to make porting easier. And once we have it all in Rust, I think then I want to split this into two parts, into one struct that creates the telemetry and another struct which does the broadcasts. Or maybe even more. I think maybe we could split this up even more. So, but my goal here is to bring it to Rust quickly, and I think the best way to do it is to move the local telemetry into the telemetry struct. Yeah, and then to later split it up again. I hope you're with me, chat. If you have objections, let me know. Underflower says, I would extract it to a dirty factory in the first step. Yeah. I want to extract it into a factory. But I don't want to refactor the C++ code. That's my thinking here. I don't want to work with the C++ code, really. I want to refactor it in Rust. So I think I can do this faster if I move this local telemetry function into my Rust telemetry class that I already have. And then when it's ported, the class is completely ported, then I can split it up into a factory function or a factory struct. Let's try this. So we need this function. So I'm going to copy it. We need this function in our telemetry rs. So in here. And obviously I can't copy paste C++ code into a Rust file. So let's just start here and rewrite the function in Rust. So this will be an fn local telemetry, and it will take self and nothing else, and it will return a telemetry data. like that. And yeah, let's just comment out all of those lines. Thumbs up from Andefnal. That's good. So yeah, 1 minute 24. Oh, and by the way, for all the viewers, for all the new viewers, if you're wondering what we're doing here, just hop on to RsNano.com and there you can read everything about this project. RsNano.com. Okay, so telemetry data. Yeah, let telemetry data is telemetry data. And let's have a look at this struct. Hamza Ali says, any advice for me from your experience? I student of computer science second semester. Any advice? Yeah, just play with everything that you can find and that is fun. Like learn not just one language, just check out many languages. That would be my advice. And then you will find languages that you find interesting and that suits what you and what you're doing want to do. Telemetry data. Okay, giveaway time. $1.04. Jubu or Jabba? I'm gonna call you Jubu. 1 nano for Jubu. Congratulations. Send. 1 nano to Jubu. Congratulations. Okay, so this is the telemetry data. And here we can just set everything. So we need the node ID. So let's use LSP to fill out the fields. And so I want to keep the same order as the Rust code. So this sets the public node ID. So I don't think we have that. We don't. So here we have to pass the node ID into our telemetry class as a key pair. So let's just do that. Node ID. And now we should be able to say node ID dot public key. And we are returning the telemetry data immediately, so we don't even have to assign it to a local variable. So we can just say telemetry data and just return it. Signature will be at the end. Next thing is block count, and this we get from ledger.block count. So self.ledger. Oh, we don't even have the ledger. Oh, come on. We don't have anything here. Yeah, let's add the ledger. And import. Let's import ledger. And let's add ledger to the constructor. Hamza asks, what you doing right now? Do you have your own blockchain? No, I don't have my own blockchain. I help with the development of Nano. So Nano is a fast and eco-friendly and feeless cryptocurrency. And I fell in love with it a couple of years ago. And now I spend a significant amount of time porting it to Rust because it is written in C++. And I believe that Rust is a better language for writing a cryptocurrency node. And I also want to make a lot of changes to the code, and I don't feel comfortable making those changes in C++. So block count. Block count. TXMJ says C++ is gross. Yeah, but don't be too mean to C++. I mean, it played a very, very important role for decades, really. So it is a very fast and powerful language, and there's so much software written in it. And I just think that we have a better option now with Rust. Cemented count is self-the-ledger. Cemented count. By the way, NanoFam, do you watch the Primeagen? I was so happy today because I saw that he had an interview with Uncle Bob. And I know that Primeagen has very different views on function length and agile and clean code and unit testing. And I listened to the interview today in my car, and it's just really, really a really good interview. So I can only recommend that. And if not, says it could still be COBOL. Oh my god. ATXMJ says, I learned it for several years before anything other language and studied under Björn Strostrup in university. You studied under Björn Strostrup, the inventor of C++. That is a cool story, man. And TDD. LFLF says, assembler is also a powerful language. Doesn't mean you should write the node in it. No, you're right. You shouldn't. Yeah, but Rust is really new. Like, when was version 1 released? I don't know, 16? 17? I don't know. It's a pretty new language. Uncheck count. How do we get the uncheck? Oh, so the uncheck count. No, I said I wanted to keep the same order. So that means we have the node ID. We have the block count. We have the cemented count. And the next is the bandwidth limit. And the bandwidth limit is from the config dot bandwidth limit. No? What is config? Oh, this is the telemetry config, not the node config. So we need the node config. Oh, this is ugly, but it's okay to make the code worse as long as we are going to make it nicer again. So if we make it bad temporarily, it's okay. So node config is a node config. Node config. ATXMJ said, I did. He's not a great professor, lol. He isn't. I watched a couple of interviews with him, and I really enjoyed them because, like, this guy wrote history with inventing C++. I'm not a C++ fan, like, not at all, but you have to give this guy, how to say, credits. Genius, though, and I learned a lot from him. Okay. 2015 was Rust 1.0 end of null. Thanks. And by the way, I started with Rust 1.0. So when it was released, I got very curious, and I read all about it, and I tried it out, and I couldn't get the simplest thing to compile. And that frustrated me so much. But yeah, I just kept trying, and then I just one day, really, I just figured out how the borrow checker wants me to write code, and then from then on it was a lot easier. So bandwidth limit is a usize. Bandwidth limit. Unchecked count. No, uptime. No. Bandwidth limit protocol version is the next. Protocol version is self dot. Where do we get it from? Network params. Oh, we have that. And then network protocol version. Uptime. How do we get the uptime? Startup time. Oh, the startup time. I guess this is a field in Node HPP. Yeah. Startup time. Startup time. Is this... Why do we use this elsewhere? In JSON handler CPP. Let's read the chat and then maybe we get an idea. ATX MJ says, I like him as a person and engineer. He just wasn't the best teacher. Oh, okay, okay, that makes sense. LFLF says, did you watch the video of the Primogen about how C is not a language anymore? I didn't. I saw the title. I had the video in my recommendations. And I didn't. I don't have that much time, actually. But I would watch so many videos if I had more spare time. Okay, startup time. So maybe we just pass the startup time into the constructor for now. As I said, we are going to make it messy and then we are going to clean it up again. So startup time is an instant. So, or maybe we can just, you know, we don't have to even pass it in. The telemetry class is created when the node is created, so we can just initialize it here with now. Startup time is instant now. Ooh, like that. The C protocol. I have to watch that video. Is it good? I bet it's good. Nano fam. So yeah. Oh, bandwidth limit is a U size. Is it a U size? And it has to be a U64. Nanomark, and if null. So unchecked. No. Startup time. Uptime. So uptime is self the startup time. What does the original code say? It says now minus startup time. And then it says seconds. So this is converts the elapsed time into seconds. So we can say startup time dot elapsed as secs. And that is a U64 and uptime is a U64. Good. Next one is unchecked count. And we get the unchecked count from the unchecked map. So let's also add the unchecked map here. Unchecked is an arc unchecked map. Unchecked map. And as you can see, like I said this in the older streams too, as you can see, we have a lot of arcs here. So arcs is shared pointers. Arcs, the arc stands for atomic reference count. And this you should never write. You shouldn't write Rust like that. So this is completely bypassing the borrow checker. I decided to do this just to be able to port the node incrementally in small steps. Because, yeah, as I said, it bypasses the borrow checker, really. But this is not idiomatic, and you can very easily create memory leaks with this. And LFL says, when will you release RsNano merch? I never thought about that. Maybe I should. Would you guys buy that? RsNano NFTs, maybe. Just kidding. Yeah, and Oh, I just want to make a quick detour here and show you how I'm planning on getting rid of all of the arcs. So so my plan is to not use arcs, and this is only possible, or the only way I found right now to make this is to not have a node class, but instead to just have a function like that. Let's call this function run node. And oh, how can I manually set the syntax? Do you know this? Set syntax. How does this work? How can I, like that? Rust. Oh, that worked. So instead of having a node class, I want to just create all the dependencies as local variables. For example, the ledger. Let's say we create the ledger and say ledger new, whatever. So this will maybe take arguments, and then we have more components. For example, our telemetry thing that we are working on. Telemetry is telemetry new, and many more. So what else do we have? Like schedulers, schedulers new, and maybe they take maybe the schedulers need the ledger. So I would just pass in the ledger as a reference, and the borrow checker would, and maybe the telemetry also uses the ledger. Who knows? So I would just pass in all the dependencies as a reference, and currently there are many threads running, and I would just use the new scoped thread capability of Rust. I don't know the syntax right now, so I think it's something like you would just say scope, and you would get a callback here with the scope, and then you could just say something like scope spawn, and here you could just spawn threads, and here I would say something like telemetry.run and schedulers.run and so on. And if there are bidirectional dependencies, we could even have them here. So let's say schedulers. How can we? Yeah, let's just say ledger would need a bidirectional runtime dependency to schedulers, which it doesn't, but just for the sake, as an example, we could even say ledger.run and then pass in the schedulers here, and this would actually work. This would actually work because this is all in a scoped thread, so the lifetimes are correct. There's nothing that can go wrong here, and this scope would just wait until all threads have finished, and then the node would destroy itself. So this is my plan. I want to have the node like that, and in that style, I could get rid of all of the arcs. So or most of the arcs. So no more arcs. And this would also solve an issue that the C++, the Nano core team had a lot of discussion recently about the start and stop patterns. And I think the start and stop patterns in the C++ code are fine right now, but I think this style is even better because you don't, there's nothing you could do wrong. So in the C++ style, you could call start twice and stop twice, and you could forget to call stop and all of those things. But with this with this style, there's nothing you could do wrong. And I like code that you can't mess up. I really like it when the code gives you an API that makes it impossible to to make a mistake. So that was a quick detour of where I'm heading with the node class. But I can only start that once we have everything in Rust, all the dependencies and all of the node code. So maybe in 6 weeks. Okay, so let's delete that and let's go back. So don't worry about all of the arcs. I'm going to get rid of all of the arcs. LFLF says, oh, this is a quite old chat message. For sure, the mug would be way cooler with the RsNano logo. Okay, I'm going to think about it. RsNano mugs. So where did we... Yeah, here. We were here. So this was the startup time. And let's just remove the things we have already. So now we need the unchecked count and unchecked. We have unchecked. Unchecked as a count. A len. Yeah, I used the Rust names because Rust uses len for everything. So I just picked len here. So this is also usize. Let's convert it into U64. And Genesis block. Genesis block. We get it from network params. Okay. Ledger. Genesis. Hash. Pure count. What is that? What is going on here? Narrowcast. Network size. So this goes to network size. The network class, I want to completely delete the network class because the network class, it does not conform to the single responsibility principle at all. So it does all kinds of different messages and things, and the functions it has, they are mostly used just by one other class. So let's say the network class has a send whatever message. That send whatever message is only used by one class, and then it has a send something else message function, and this send something else message function is only used by another class. So what I'm doing, or what I was doing, is just inline those network class functions into the places that use them, and now the network class is really small in RsNano, and I'm planning on deleting it. So instead of the network class, I want to use the channels, the TCP channels class, which manages all of the channels. Oh, we have that already. We don't even have to pass it in. So let's go back down to local telemetry, and your count is channels .len.size count. Here I called it count. Let's rename it to len. I want to let's use 64. I want to have a consistent naming style. 32. Okay, then as U32. Let's also rename it to len. Okay. No method len found. Did the renaming? No, there it is. Okay. Okay, so set peer count. The next one is the account count from the ledger again. Oh, did I miss the giveaway? Chat. Did I miss the giveaway? Oh, I did. You guys are not paying attention. Johnny! Yeah, Johnny, congratulations. LF says we are too focused on the code. Okay, that's good. That's a good excuse. Close, end of null. Yeah, close. Congrats, Johnny. Okay. Ledger count and major version, minor version, patch version, pre-release version, and we get these. Johnny says, "Oh, thanks. You're welcome." We get these values from CMake. CMake passes them into the C++ compiler as definitions. Is that the word? As definitions. And we don't have access to them here. So I would say that should we just hard code it for now and fix it later? I think yes. I don't want to spend time now figuring out how to get these values from the build script. So let's just hard code it for now and let's fix it later. So major version is 27.0, patch version 0, pre-release version. What is the pre-release version? Let's just put 0. And then let's add a to-do. Get this from CMake. And yeah, these two. Count, release version. So the next is maker. So this is the maker code. So this is now funny because this is the with maker they mean the producer of the node software, and this is now something special for us because we are RsNano, so we won't use the same maker code as the C++ node, and we already have one. And our maker code is telemetry maker. Let's see. What is our telemetry maker? Or I think it is an enum, really. Is it an enum? Maker. Yeah, telemetry maker. RsNano. And here, this is the enum telemetry maker. So the value 3 indicates that a node is running RsNano. SU8. Okay. Timestamp is just now. Oh no, what is it? System time. System time. System time. System time now. Active difficulty. Wenderson says, Nano ist das Licht. Do you speak German, Wenderson? I'm impressed. Nano is the light. Active difficulty is active the default difficulty. So now we have to jump back into the C++ code and find out what this does. So the default difficulty. Oh, okay, we are just going. Yeah, we're just going to directly call into the work thresholds with the work version. So let's go back to. Let's go back to here and let's say. Is this a network params? Work. Difficulty. Work version root. What? Is there no way to get a difficulty just for the work version? Base difficulty. I think this one. The base threshold is the maximum of all thresholds and is used for all work multiplier calculations. I think this one. We need this one. But let's just go back to the C++ code and verify that this is actually the one we want. So this calls into our Rust code base, threshold base. No. Threshold base. So what does this do? Creates a work version and then it calls threshold base. Oh! I didn't see that. Yeah, but this just returns self.base. Okay, but let's just keep it the same way. Let's just call this function. Let's just call this function. So threshold base. Work version. There's only one work version. So this is just to future-proof it, I think. Winnerson says not yet. Yeah, German is difficult. Unknown data. What is unknown data? So we have maker, timestamp, active difficulty, and what is unknown data? Vec U8. So I think this can just be an empty vec. We don't have any unknown data. And then signature. We have to sign this. So maybe we can just start with an empty signature here. Is there a zero function? No. Or a default? Yeah. Now make sure this is the final operation, yeah. So here we, oh, okay, so we have to keep it as a variable. Telemetry data. And we have to make it mutable because we are going to change the signature. Sign. Is there a sign? Yeah, and it takes a key pair. So self.node ID. And what? Oh. Semicolon missing. And consider it, yeah, and now we can return. We can return it. So that's it, chat. That's it. We have the local telemetry function in Rust. But we don't use it yet, so we could so should we use it immediately or should we just port the remainder of the class? How late is it? 10. 1 hour left. You know what? I wanna use it immediately, because maybe I will forget about it else if I don't do it now. So let's just fix all of the errors we still have. Unchecked. We don't have unchecked in here. Checked is an arg unchecked map. What else is wrong? Oh, it doesn't return anything? Ooh, what did I do here? I said... Ow. Unexpected. What happened to my changes? Okay, no more errors in here, so let's jump to the FFI functions. I don't think we have FFI functions yet for telemetry. Giveaway time. ATXMJ says, gotta run, we'll try to join for the next one. Thank you for doing these, Gustav. Oh, thanks for joining. Okay, Elibob won. Elibob, congratulations. Yeah, Elibob. Bob won Nano. All right, so yeah, let's start by creating an a file for the FFI functions for telemetry. So let's go to the FFI folder, and where's this one in Node? Node, where's Node? I don't even have that here. Yeah, this doesn't matter. I'm just gonna put it whatever, wherever. Let's say telemetry. Create the file. Let's add. Oh, you don't see that. Let's add. LF says, end of not winning anything today. Rigged. Oh, we still have 1 hour. Still a couple of nanos to give away. So telemetry handle. Is this also an arc? Let's make everything an arc. Oh, struct missing. And is telemetry public? Let's see. Is it? Let's make this, let's say pub use, so that we can directly import it. So back to our FFI file, and let's import arc, let's import telemetry. And yeah, now let's create the FFI functions that we need. So no mangle, which means don't change the name, so that we can call it from C. C calling convention. Telemetry create returns a raw pointer to the telemetry handle. So this is the usual stuff that I have written thousands of times now. And I tried creating a macro for this, but unfortunately cbindgen, the tool that I use to create the header files, it doesn't work with macros. Into raw. That would save me a bit of typing. Telemetry handle. Telemetry new. And here we have all of those things that we need. So we need a telemetry config. I think telemetry config, I don't think we have any data structure for that yet. But it's just 2 bools, so I'm lazy now, and I'm just going to pass these 2 bools directly. Enable ongoing requests, enable ongoing broadcasts. Yeah, let's do that. Oh, sorry. So let's say enable ongoing requests is bool and enable ongoing. Oh, I don't even have to do that because these values are in the node config and we have to pass it to Rust anyways. So let's just pass the node config DTO. And then let's convert the node config DTO into the real thing. Node config drive from node config unwrap. So now we have the node config, and from the node config we can just clone the config, the telemetry config. Can't we? We can't. Okay, we have to check the C++ code. But where do we look? Telemetry HPP. So, oh, here it is. From the flags. Okay, so we get these values from the flags and not from the node config. Okay, then I'm just going to pass two bools. Two Boolean values. We still need the node config though. So enable, what was it? Enable ongoing, I forgot the name. Enable ongoing requests, enable ongoing broadcasts. Ongoing requests and enable ongoing broadcasts. And here we can now say telemetry config. With that. Okay. So why isn't this reformatting the code? Missing type for function parameter. Oh. Bool missing. You forgot bool. LF, you were quicker than me. Thank you. So what else? We need stats, which is a stat handle. We need ledger, which is a ledger handle. Then unchecked is an unchecked map handle. Unchecked info? No, unchecked. What is unchecked? Unchecked map handle. Checked. Maybe it isn't public. Yeah. I think it isn't public. Let's see. Unchecked map. Unchecked map is a mod. Yeah. Pub use. Checked map, unchecked map handle. So now it is public. All right. Unchecked map. The next thing is network parents. Network parents is a network parents DTO. Channels is a channels TCP channels handle. And node ID. I'm just going to take the raw bytes to the private key and recreate the public key from there. And what is the last thing? Notify? What was notify? What was notify? Oh, this is a callback. Oh, this is a callback. Oh, no. Let's first finish these things and then let's add the notify callback. So why don't I see any errors? Let's just restart. Let's just... Oh, I know which one, the buffer. This one is not saved, but let's delete this. Okay. Let's restart. Telemetry RS. No. Telemetry RS. And LSP signature handler. Oh, giveaway time. Nano ETH again. Congratulations. So, 1 nano fearlessly, instantly. Eco-friendly. Congrats, Nano. So, is my LSP down again? Let's try again. So, where are the LSP errors? Not there. Strange. Okay, so network params. Oh, now we have them. Params is network params. Try from network params. Channels. Arc clone. And oh, we have to clone all of them. Clone ledger. Stats. Checked map 2. So node ID, we have to recreate the key pair from the private key. So let's say node ID is... Is there a function for creating a p key pair from a pointer? No. From private key bytes. So this needs a byte slice, but we can create a byte slice with where is this? From raw parts, node ID, and the length is, what's the length? 32 bytes, right? How big is the private key? I think the function tells me. No? How big is it? Yeah, 32 bytes. But this is... Oh, it takes... No, just a... This... Oh, this operation is unsafe, so we have to say unsafe. Okay. I think this It's looking good. We have, so now only the notify is missing. So we have to add it here somehow. So we need a callback type. Ooh, what does the notify callback look like? It gets, here it is. Here it is. Telemetry data. Channel enum. So we have to define a callback type. Notify telemetry. Notify callback is so it will take a void pointer which will contain a pointer to the C++ callback. Then it will take, what did I say? Telemetry data and channel enum. So it will take the telemetry data handle. We don't have something like that? Is there one? There is one. But where? Oh. Telemetry data? Where is it? Telemetry ACK RS. So again, I think this is just not public, so we have to export it. So cap use. Okay, that was it. So this takes telemetry, also as a raw pointer, telemetry data handle, and a channel, right? Channel, yeah. So also a raw pointer to the channel. So this is our callback type. And we have to also pass it in. So we say notify callback is the telemetry notify callback. And additionally, we have to pass in a void pointer for which actually contains the pointer to the C++ callback. And I call this callback context is a C void. And we need a function that deletes this pointer. So delete context is a void pointer callback. So these callbacks things are actually like, they are confusing and very ugly. And I have written them a lot of times already, so that's why I know what I want to do here, but I totally get it if you guys think, oh my god, what's that? So I have to wrap the callback context into with my helper class that I wrote, context wrapper, which handles the deletion of the context pointer when our Rust callbacks goes out of scope. So this takes the callback context. Let's write this, call this wrapper, callback context, and the delete context function. And now we wrap the C callback function into our own. And this will take the data and the channel. And now it has to convert the data into a raw pointer so that we can pass it to C++. So data handle is telemetry. Data handle, does it have a new? No. Let's create a new function. Self data. Yes. And then we can use that new function down there. Like that. And we can use it here. The telemetry data is data. So this is the data handle, and then we need the channel handle. And that is a TCP channels handle. Oh, this also doesn't have a new function. Yeah, let's also create one. Our TCP channels. Oh my god. Oh, channels. Giveaway time. But let me just quickly finish this. So, also box into raw. Box new self. Channels. And then we can just say new channels. And here we have to finish it, but let's spin the wheel. Nano 4. Is it Johnny? Is it Andifnal? Andifnal, your rigging doesn't work this time. Johnny gets 1 nano. Congratulations. Data handle, channel handle. And so to do, yeah. So we have these, and now we can call our C callback. Notify callback. First we have to give the context pointer. Context wrapper. Dot get context. Then we have to pass the data handle and then the channel handle. And our C code, C++ code, is then responsible for deleting those all of those handles. I think that's it. So now I want to switch to the C++ side and call this FFI function, and we need a delete function first. So maybe we start with we add a delete function too, because we need it. So handle is a raw pointer, and we are just going to drop it. Box from raw. So now we have a destroy function and a create function, and now we can use that in the C++ code. So let's do that. Let's add, so this is the C++ code, and let's add where it should be public because we are going to use it from other places. So let's add it here. RsNano telemetry handle pointer, And we have to initialize it in the constructor, we have to delete it in the destructor, and we have to make sure that telemetry is never copied, because we can't copy and double free that handle. So let's say telemetry, copy constructor, delete. And now we can initialize the handle here. With all of those things. And in the destructor, we can call destroy. Telemetry, destroy. Oh, why doesn't it show now? It does. Okay. So here we have a lot of things we have to pass in now. Enable ongoing requests. This is not flags, so let's just copy that. Oh no, we can just copy it from the config. Config a.enable ongoing requests. Config a.enable ongoing broadcasts. And we need the node config DTO. Is node config DTO. Node config DTO. And my nanomag is empty. NanoFam. Cheers. Okay. And we still have time. Half an hour left. So we should get this to work. So stats handle. We need the stats handle, so we can give that from node stats handle. Ledger handle, same thing. Node ledger handle. Unchecked map handle, same node. Checked handle. The network params DTO. We have to convert it into DTO first. That network param network DTO and TCP channels. Network TCP channels. And then the node ID is node ID dot private key bytes data. And okay, now the callback stuff. Now we need the notify callback stuff. Let's add that here. Void notify wrapper. And what was the arguments? It was a void pointer for the context. An RsNano telemetry data handle for the data, and a channel handle. Yeah, channel handle. Channel handle of the channel. And this is our notify wrapper, and we give it here notify wrapper. Oh. And then it needs the context and the delete notify context. So we still need a function called delete notify context. Okay, so we have to implement them, and we need the context. So what is the context? What is the context? Oh, where is the notify callback? Where is it? Oh. I thought we have access to it in the constructor, but we don't. Where is the notify? There is none. Oh, I have to think. What did I do there on Monday? I think... here it is. Observer's telemetry notify. So this is an indirection. It goes to the observer's class. Nano is still the light, says Wenderson. You are right. It is the light. So, observer's telemetry notify. So, okay. We can't just... node observers. I think it's a shared pointer in the node anyway, so we can just say context is a new shared pointer to Nano observer set. No, what was it? Not observer set. Node observers. And we just give it the node A servers field. Is that right? This is a shared pointer. Yeah. So this is the context. Oh yeah. Giveaway time. Oh, wait a second. Is Wenderson on there? Sorry. No. This is not. Let's cancel it. Let's cancel it. I'm sorry. Let's cancel it. You are not on there, Wenderson. Sorry for that. So now, this is the one. ATXMJ. Congratulations. 1 nano for you. Okay. Congrats. I really don't like this callback stuff. It's always so complex, really. Okay, so this is the context. So, but we are almost there. So we just have to implement the delete, which just casts our void pointer back into the callback or into the observers. Pointer, and then we delete it. And in the wrapper, callback wrapper, we just call it observers. Observers. telemetry notify. Yeah, so telemetry data. Oh, come on. Telemetry data. Data handle. And what about the channel? I think I have a helper function for creating the channel from the handle. Channel. Here, channel handle to channel. And now we can pass this to notify. Data. Channel. Sorry, NanoFam, for yeah, working with this ugly stuff here. But we're done. We are done here. So now we can do the thing that I actually wanted to do. And if now says he's gone, yeah, it doesn't matter. So he's gone. He still can keep the nano. So yeah, so now we create the handle. We destroy the handle. And what I actually wanted to do was I wanted to use our new function for creating local telemetry data. And that means I have to add an FFI function still for that. So a function that is called local telemetry. And this will return raw pointer to telemetry data handle. And here it will just call into our local telemetry function. Oh, is it not public? Telemetry? No, it's private. Let's make it public. And sorry, let's make it public. And this, we have to convert this into the telemetry data handle. Like that. Okay. Okay, NanoFam, we can use this now in our C++ code. So let's add this function here too. Let's add it wherever. So let's say telemetry data, local telemetry, and let's add it there. Nano telemetry, local telemetry, and this will return telemetry local telemetry handle. And now that we have that, we can call this in our node.cpp. Where is it? Local telemetry. So let's replace this now with let's replace this with our return telemetry, the local telemetry. Okay, I want to test this, or I want to run the tests now. Let's format the code first before I compile, because compilation will take a while. And then we run the tests, and if everything passes, we commit it. and we push it to GitHub. Okay, build. Let's make, yeah, core tests first and RPC tests later. Okay, now we have some time to talk. Let's see. Oh, I missed something in chat again. And if not, he will get a surprise notification. Yeah, nothing better than receiving some nanos unexpectedly. Compilation error. Where? Telemetry RS. Where? What's wrong? Telemetry RS57. Arguments to this function are incorrect. Why don't I get the errors here? Node ID. Oh, it's a result. Yeah, let's unwrap. Roger, Cruz, welcome. I think you are in the address book. Aren't you? Address book. Roger, yeah, so let's add you to the wheel. And another mistake in line 46. And what was the message here? Expected mute channel handle found. Mute TCP channels handle. TCP channels handle? I man, no, this is what? What is channel? No. This is a channel handle, not a TCP channel handle. Yeah, I think this should work. No, it doesn't. Line 45, expected arc channel, you know, found TCP channels handle. Oh, not channels. That was the problem. This should be called channel. And there is another mistake in notify expected due to this. Type mismatch in closure arguments. 58. Notify. Arc channel enum telemetry data. What does the callback look like? It's a reference to telemetry data and reference to arc channel enum. Okay, maybe we should give the types here. So telemetry data and arc. What is it? Channel. And then the callback. Yeah, I think we have to clone here now. Let's see. Hey Gustav, I'm late to see the big refactoring. No, you're not. You're not. I'm still porting the last bits, and the big refactoring streams will start. I don't know when they will start, but soon, because we are almost done with porting the node class, and then the big refactorings can start. Yeah, so let's do the giveaway, and let's wait for the compiler to finish. Still compiling. Illibob. No, yeah, Illibob. Oh, pies, that was close. That was really close. "20 minutes still left. LFLF says, what's the percentage ported? Did you reach 50% already? No, but it went up significantly. Let's see. It went up significantly. Because I worked only on porting code last week. And now I'm very much behind with merging upstream commits. I think I'm more than 80 commits behind now. So that means I have to spend, I don't know, the next 2 weeks or 3 weeks merging all of those changes back into RsNano. And that's such a boring task. Can you imagine resolving merge conflicts for 8 hours, 9 hours straight? Yeah, 46.49. Yeah, I was really, really productive this week. Very productive. Especially with my new computer, which is so incredibly fast that I can work uninterrupted. So let's restart the timer. Still 20 minutes left, so lots of time left. Are you updating the diagram, LFLF? Let's give a shout out to LFLF who made this beautiful website here. So I had an older one which I created myself, but I'm not a web designer, and this one here is just way better now. I'm really happy with it. LFLF made it. So still already updated it. So let's see, how does it look? Let's reload. No, let's reload. Maybe it takes a minute. Let's try again. Yeah. Oh, this looks good. Art with Brenda. Hey. How are you doing? Doing good. How are you? So, check this out. 46.5%. That is just a huge spike. Maybe I could find out those values. But yeah, right. I don't think we need them. It just shows that we're really getting there. 46%. Where are you from, Art with Brenda? I'm from Germany, Stuttgart, Germany. %91%, almost there. So now the usual question, NanoFam. Will it work? What do you think? Will it work? Did we break anything? Roger Cruz says, forgot about the giveaway and your nano address, but I think I have you already in my address book. Let's check that. Or do you have a new address? Oh, did I just delete something? What was that? Here, 3D, let's compare. Oh no, it's a new one. It's a new address. Okay, so let's update that. Oh, it's coming from here. So like that. Okay, updated. Roger, updated. Yeah, still have the keys. Good. Okay, no, I updated it, Roger, so Got the new one. Yeah, really happy with this diagram. Okay, linking. We are getting there, Okay, done. Let's run the tests. Let's run the tests. And on my office computer, in the new one, these tests, they are just, yeah, they just run through like, whoop, you could just see the numbers go up so fast. Oh, here we have, okay, that's expected. So the telemetry data that we hard-coded makes at least one test fail. Okay. And another one, and another one. So the, what is it? Pre-release version. Okay, so I have to find a better way to get this data. I can't hard-code it here. Or maybe I can just hard-code it to these values. For now. I mean, this is a temporary solution anyways. So 3 tests fail, and all of them are related to... all of them are related to telemetry versions, the node version, re-release version, which is a C. Get pre-release node version. Any ideas, chat? What we could do here? I think I just want to hard code it to that pre-release node version to a C. Let's try. Pre-release version. Oh, it's a byte. What is ASCII C character? ASCII table. What is it? Was it a lowercase or an uppercase? Lowercase c is a 99. Okay. So the pre-release version is a 99. So let's just do that. And let's compile again. So this should not take long now because it is only recompiling the Rust code. Yeah, let's run the tests. This maybe did it. Okay, while those tests run, let's do the giveaway right now. We have time right now, so let's do the giveaway now. Oh, and if null. No, it's not you, it's Roger. Roger. 1 nano for you, Roger. Congratulations. I'm going to bed, says and if null. Not really. Yeah. Okay. Yeah, the tests pass. That's nice to see. So let's commit everything now. Roger says, finally won something in my life. Yeah. Isn't that good? And it's Nano. What better thing to win? Okay, let's add everything. Let's diff quickly. We removed this. Added these ugly wrapper codes. This ugly wrapper code for the notify callback. We have these functions here. Telemetry RS. Yeah, let's commit all of that. And with the message, what is the commit message? Port local telemetry. Node, node. Local telemetry. And push. So now only 9 minutes left. I think this is not enough time to start anything new. So I'm going to finish porting the telemetry class, which is just these two functions, I think. Maybe one or two more. And then the telemetry is ported. And then there's only a couple of others left. And yeah, I'm really excited, NanoFam. I'm really excited that the full Rust node is coming so close. So let's let's call this a day. And oh, I think we still have one Nano left. Do we? Counts? No, 2? What? Why do we have... No, there was a mistake here. 1 Nano left. Okay, so we have 1 Nano left. Let's give away the last Nano. Ready? NanoFam, let's go. The last Nano is for... Jubu! Congratulations. Jubu gets 1 Nano. Okay, so that was it. Wish you all a good night. Have a great week. And see you next time. Next Tuesday, same time, 7 p.m. UTC. And yeah, visit our Discord server if you wanna help, or if you have questions or just want to chat about RsNano. And visit rsnano.com and have a look at this great chart. So, and thanks again, LFLF, for making this website. So, guys, have a good night. See you next week. Bye-bye.